Yeah, hello everyone. I'm going to tell you basically some tips and tricks that I've learned kind of over the years working Kubernetes. A little bit about me before we kick off. So I'm currently a platform engineer at Giant Swarm. I've been working with Kubernetes about 5 or 6 years now, and in that time, I've kind of had every kind of user role that you have with Kubernetes. I started out as an app developer, so I was deploying things onto Kubernetes. I then moved into actually building tooling for Kubernetes, so either operators on top of it or like Terraform modules and stuff for other teams to then use. And finally moved into a more cluster operator role where we're managing clusters for customers and things like that. So I've kind of got a bit of experience of different aspects of working with Kubernetes. My goal today is to basically share 10 tips that I've come up with over these years in a way that we're going to start off with something that hopefully everybody here today can make use of if they're not already, all the way up to some more advanced things that if you really want to get into the nitty-gritty, you can kind of take advantage of those and really make Kubernetes work for you rather than it stressing you out when things go wrong. So the first 5 we're going to go through, like I said, hopefully everyone can kind of pick up. 6 to 7, it'll be good to have a little bit of like old school ops knowledge. So working with like Linux systems and things like that, we're going to bring in a little bit of that. And then the 8 to 10, we're going to need a little bit of programming. So generally speaking, this will be in Go, but not necessarily needed. There are tools we can use and we'll go through those. So let's kick off. Okay, this first one's a little bit tongue-in-cheek. This is what we provide at Giant Swarm. We manage clusters for other people. So I'm putting it in there. It is a joke, but in large organizations, it's a sensible option to consider, right? Not everybody needs to be Kubernetes experts. Pass that problem on to somebody else and get on with whatever's making your business money. But that's not why we're all here today. So, number one, my number one tip that I think everybody working with Kubernetes should learn is learn to love your terminal. You will spend a lot of time on your terminal debugging clusters, working with clusters, whatever. So learn to love it. Whatever you use, whether you use Bash, whether you use Fish, whether you use PowerShell, it doesn't matter as long as you take a bit of time to get comfortable with the features of your terminal. It's good to kind of look out for these like RC files, so .bash RC, .zsh RC, and things like that. These allow you to kind of customize your terminal setup and allow you to create kind of utilities and helper functions that aid you further down the line. One thing that I use heavily in my environment is the alias functionality in Bash or ZSH or whatever, which allows me to create my own functions that I can use in Bash. A lot of times these wrap together a lot of different CLI tools that I use into one little command that I just need to remember that. So when I'm woken up at like 1 a.m. with an alert, I don't have to remember this 47 character long command. I just have to remember this one little short command and it does it all for me. It's wonderful. If you're not sure how to get started, look out for dot files on GitHub. Mine are here if you're interested, but a lot of people share their dot files, so their .bash RC, their .bash whatever, and you can kind of see what other people are using and maybe take some of those and tweak them to your own usage. Number 2, learn to love kubectl. So if you're working with Kubernetes clusters, kubectl is kind of the basic interface with Kubernetes, right? This is where you get all your information from. One of the things that I will do personally, and this goes back to number 1, is I will alias kubectl to K, because that saves me so much time having to mistakenly type out kubectl every time, because I am terrible at typing. Just typing out K, shorten that down, and then I can kind of build on top of that. So then I've got like K get pods rather than kubectl get pods, blah, blah, blah. The documentation for the kubectl command, there's a nice big 1-page documentation that goes through all of the commands you can use, all the arguments. It's fantastic. If you know kind of what you're trying to do with kubectl but not sure exactly how it works, there's also kubectl explain. You can then provide that with, for example, as you can see on the right here, pods.spec.containers, and that will give you all of the documentation about the containers property in the pod spec right there in your terminal. So you don't need to go off to some third-party website, to the Kubernetes documentation or whatever. You can get it all there. That's really useful if you know specifically what you're looking for, but if it's a more general thing, I recommend going to the official docs. Cool. So if you're working with many Kubernetes clusters, things get complicated very quickly. I know I've accidentally done something in production when I was meant to do it in dev because I was on the wrong Kubernetes cluster in my context. Yeah, it's not great, but these things happen, so we want to try and ease this problem as much as we can. So there's some tools out there that make it easier to deal with multiple Kubernetes contexts, multiple Kubernetes like contracts and things like that. Kube-Context and kubeNS, they're kind of both the same tool. Gives you two CLI tools under the same installation. Kubi and kubeswitch, they all effectively do the same thing. They allow you to manage multiple Kubernetes clusters and switch between them easily. I personally use kubeswitch, the one down at the bottom. You can see it on the right here. The main reason I like that is you can actually point it at a directory of YAML files. So you can actually split out your Kubernetes, your Kubernetes kube configs into multiple files, and it will pull them all in together for you, but you can then manage them separately in the file system. It's quite nice. And you can get this nice little interface where you can kind of switch through. And then you can also pull that out into your terminal to show it. So when it loops back around, it'll show that I'm connected to the kind cluster. There you go, in the blue there. So that kind of aids me from not doing things in production when I shouldn't. But if you're a more visual person, you like to actually interact in a dynamic way, you don't want to have to be doing kube control get, kube control patch, or all that kind of thing. I highly recommend the K9S tool. So this is an interactive CLI tool. You point it at your Kubernetes cluster and it allows you to access pods, it allows you to access logs, it allows you to edit files, it allows you to view files, look at events, all this kind of thing. Basically, anything you can do with kube control, it allows you to do in a dynamic way with interactive feedback and all this kind of thing. So this is the kind of my go-to whenever I'm looking at any cluster to start with. If you are a more visual inclined person, you'd rather do something outside of the terminal and have something a bit more kind of UI-based, click-based, whatever. I could also recommend OpenLens. So this does the same sort of thing, but as a kind of a desktop application. It gives you nice graphs of like resource usage, things like that. And it allows you to look at all your pods, your logs, edit things, all this kind of thing. So I like these as a nice overview of my cluster. So that just from the start, I can kind of get a sense of, okay, there's a big red error here. That's probably the area I should start looking into when things are wrong. Cool. So we've got a bunch of basic stuff out of the way, hopefully. Now is where we can start kind of building on top of things and creating our own customizations, let's say. So for those that don't know, kube control, the CLI, it has a built-in plugin mechanism. Basically anything on your path in your terminal that is prefixed with kube control hyphen becomes a plugin. So for example, this example that I've got on the right here, this kubecontrol-hello, this is just a bash file that just echoes out hello world. If I have that somewhere in my path, I can then do kubecontrol-hello, and it'll run that plugin for me. Now, it doesn't really get any special powers from being a plugin. It just kind of is a nice hooking method. You still have to then handle things like authentication, pulling in from Kubernetes and all this kind of thing. But it does mean that you can then kind of bundle your things together. If you want to look out for third-party ones, there is a project called Crew, which is a package manager for Kubernetes, for kube control plugins. You can go to the URL as here. Once that's installed, you can then easily use the Crew plugin for kube control to install other plugins for kube control. Some of my favorite ones I've listed down here. So Stern is a really good one for viewing logs of multiple pods. So it allows you, say, do like a wildcard search for my app name, and it'll search like my app name's backend, front end, whatever, and stream all the logs together in one go. And then I can do filtering and all this kind of things. Really nice tool. Tree allows me to look at a resource within Kubernetes and visually view its owner reference hierarchy. So if a cluster belongs to if a resource within the cluster belongs to another resource through an owner reference, so for example, a pod belonging to a replica set belonging to a deployment, tree will show this in a nice little graphical way. Outdated is a great way of having a look at what containers you are running in your cluster that are using an old image version, so you can quickly get a nice little list and know what you need to update so you're all on the latest. And GS, finally, because it's what we use at Giant Swarm to actually interact with our Giant Swarm clusters. It's got some niceties that we give in there for our customers to make it easier for them to work with the clusters that we manage for them. So we've built our own plugin to aid them. So that was nice and quick. We've gone through those, and hopefully nobody's kind of scared off by those. They're all things that I think everybody should be able to pick up kind of nice and easy. Hopefully a lot of those are already being done. Now we're going to dig into some of the tips that kind of need a bit more old school knowledge. So if you come from an ops background, these will be kind of like obvious to you, I hope. But let's see how things go. So pod debugging. So this is something I do, let's say 90% of my time. When clusters are going wrong, I'm having to figure out what it is, going into pods, seeing what's going wrong, going into nodes, see what's going wrong. To make pod debugging easier, I've got a few little utilities that I use. So this is a callback again to tip number 1. So I'm using an alias in my bash RC to create a command line function called kshell. And what kshell will do, it will run a kube control command. So it will do a kube control run. It'll use a bash image and drop me straight into the shell and clean it up after I'm done. And this allows me to launch a pod in the cluster that I can then use for like general debugging. My main use case of this is when DNS or networking of some kind is not working. I will instantly load up a brand new shell where I know it's got a clean slate, and I will start doing, NS lookup to see if I can actually resolve host names. Can I curl out to the external network? If those fail, then I know something's going wrong with the networking in my cluster. So I can look at then core DNS, or I can look at network policies, things like that. So here's an example. So using it for NS lookup is 90% of what I use this for. So this allows me to then see whether core DNS is causing problems, whether it's actually resolving correctly to an external IP, things like that. A second one I want to talk about is kubecontrol exec. So this is built into kubecontrol, and it allows you to drop into a running container within your cluster. So if you've got an application that's going a bit funny, but you don't necessarily know why, you can get a shell into that container to start poking around. We can have a look maybe at some of the files that it's creating. Maybe something's got a bit corrupted or saved as a wrong format, whatever. We can start debugging that. There are some caveats with this approach though. So the container that you're trying to debug has to have an interactive shell environment within the container. So for those scenarios where, for example, you're building a Go application, and you're just building the binary within the container and nothing else, you can't use this for those sort of scenarios. You're also limited to whatever's already available in the container, or what you could possibly pull in while running in the container. So you won't necessarily have debug tools built into this container image, hopefully, that you could then help. So it is kind of limited into, okay, what's on the file system, what's networking looking like, things like that. And finally, the container actually needs to be running. So if you've got a crash looping pod, this is only going to work for like a second or something before your pod crashes, and you're then kicked out of the shell. So the top example here is, for example, where we have a Go binary that is all that's in the container. So you won't be able to get a shell in there because there is no shell environment. There's nothing to actually attach to. There's just your Go binary. So that won't work. But we do have some alternatives we can use. So from Kubernetes 1.23, there's a new kubecontrol command called kubecontrol debug. And what this allows you to do is allows you to create an ephemeral container inside your broken pod alongside your broken container. Now, It's still limited in what you can do because you're not in the actual container that's broken, but it allows you to do some debugging as though you are that application. So it will be running in the same context as your pod. So things like network policies, things like DNS lookup, things like the environment variables that are available and things like that. You'll be able to have access to those, and you can then do some debugging in that regards to why potentially this container of yours is crashing in that pod. So let's have a look at a little example. So let's imagine that I've got a pod running in my container. Sorry, a pod running in my cluster that's got a container that is just a bash image that just exits immediately. So it's effectively, it's crash looping, right? So we then do a get pods and we see, oh, crash loop, back off. Keeps trying to run, it keeps exiting, keeps trying to run, keeps exiting. So in this scenario, I can use the kubectl debug command and get another bash container alongside it, and I can start investigating then. Now in this specific scenario, it's not going to do as much use because it's actually the image itself that's saying, oh, I'm done. But it's a good example of how you can get this container alongside. So I've kind of touched on three different ways of debugging pods that I use on a day-to-day basis and the kind of scenarios where they are useful. So if you are looking at issues that are affecting multiple workloads in your cluster, you're not quite sure what the cause is, maybe networking, maybe something else, maybe some sort of policy-based issue, I recommend starting off with K-Shell, get a new clean state in there, and you can kind of have a little poke around, see what's going on. If it's a particular workload that is failing, and it's a workload that has an environment you can drop into, so something that has a shell. So for example, a Node.js application is a good example of this. I recommend using kubectl exec, so you can drop straight in there and have a poke around, see what's going on with that specific workload. Now, if your workload is crash looping, or if it's not got an environment where you can do that, your final choice then is to use kubectl debug to figure out what's going on. If none of these work, you kind of have to go back to basics and say, okay, let's have a look at how the Docker image is built and debug it from there. Maybe I can run it locally, that kind of thing. So this nicely follows on to node debugging. So when it's not the pod that's going wrong, but something more widespread, generally it'll be an issue with that particular node or multiple nodes within the cluster. So we've got a few options to look at nodes, to debug nodes. So again, using the same kubectl debug that was introduced in 1.23, we can use the same functionality to debug a node itself rather than a pod. In this scenario, we need to provide it with the node that we are wanting to debug and the image that we are wanting to use to do the debugging. So depending on what the problem is and what tools you need to investigate, you can change this image. So I generally just go for an Alpine because it's nice and quick and it's generally got the basic stuff that I need to debug. If your problem's a bit more complex and you need more tools, switch that out for Ubuntu or some specific that you've built as a debug toolkit or whatever that may be. When you run this command, what it does is a pod is launched in your cluster, scheduled specifically onto that node, and it's running a privileged mode where it attaches to the host system's root namespace. What this means is that you can access from that pod the processes running directly on the node itself, and you get access to the host node's root file system at the /host directory within the pod. So you can then start digging around on the node itself to see if something's wrong. So maybe I want to look at the kubelet config to see if that's looking correct, or I want to look into the var/logs to see if there's anything weird in there. Some of you may be wondering why not just SSH onto the node and debugging it that way. So I personally prefer to have ephemeral infrastructure. So I want to make sure that my infrastructure, when it's running, is not tampered with. It is exactly what I expect it to be. So I generally will run host nodes with no port 22 open, so no SSH available. So that's not there. So you can't get into a state where you SSH onto a node, do a little fix, and then forget about it. And when that node's gone, the fix is gone, kind of thing. One thing to note with this scenario, there are other ways to achieve the same sort of result. So if you have older clusters between 123, Ian Coldwater tweeted out this very nice little one-liner that you can run that effectively does the same thing. So it allows you to, it uses this ns enter command to get you onto the host system in the same sort of way. There are some limitations with this approach though. So the host node itself needs an interactive shell to be able to do it. Now you may think that that's a common thing, that every host node will have this. Now if you've used Talos, for example, that's a Kubernetes distribution, that does not have a host shell. So this approach will not work on that, whereas kubectl debug will. There are also some alternatives of this. So I've built one in the past called kubessh that does a very similar thing. And at GiantSwarm, we've also got a kubectl plugin that does the same thing. And if you know Duffy, he's actually got this on stickers as well, which is pretty cool. So if you want it on your laptop, it's very cool. So, cool. We've gone through all the old school ops sort of things. So actually debugging issues, things like that. We're comfortable in our terminal. We've got our little utilities. We know how to then see when things go wrong. Let's start looking at things that need a little bit more time investment, needs us to actually build something. So this is where I think a lot of the power really comes out of it. First thing I want to talk about is webhooks. Now I've got kind of a love-hate relationship with webhooks, and if anybody's interested, I can talk at length about that later on today. I have other talks about this kind of scenario. But webhooks in Kubernetes are very, very powerful if used correctly. So there's two types of webhooks that we're going to talk about. There is a third one that is a CRD conversion webhook, but we're going to put that to one side. That's not relevant for what we're talking about here. We are going to be talking about validating webhooks and mutating webhooks. Validated webhook, as it sounds like, allows you to block some sort of action based on whether it meets certain criteria. Mutating webhook is very similar, but it allows you to actually change the payload of a request on the fly. What you can do with webhooks is implement some more advanced access control behavior. So we all know in Kubernetes you have RBAC, so role-based access control. So this allows us to scope what users are allowed to do and not to do in a Kubernetes cluster. But these are very additive in the way that they work. So RBAC, you give people permissions. You give them permission to access them. You give it. There's no way of taking away a permission without taking away the whole thing. What a webhook allows you to do is it allows you to be really specific about a permission you want to give somebody. So if, as a cluster admin, for example, I want to block other cluster admins from being able to delete the kube system namespace. Now, cluster admins have ability to do everything, right? That's cluster admin. But I could have a webhook that could block that specific action and effectively take away that RBAC permission that they've been given. It also allows you to do things like defaulting. So this is where the mutating webhook comes in. So you can have a mutating webhook that, for example, adds a bunch of default labels to applications. So for example, I have a namespace that is for my team super awesome. And I want to make sure that every application, every pod, every deployment, whatever, in that namespace has a specific set of labels attached to it. I can have a mutating webhook that will do that automatically without then having to put the effort back onto the application teams themselves, building out all the YAML and all that kind of thing. Can also enforce policies. So, for example, if in our organization we don't want to use the latest tag, we want to make sure we're always using a tagged build or a SHA build or something like that, this is where webhooks come into power. So they will allow us to, on pod creation, block any where the image has a latest tag, for example. The thing that I'm most interested in with this sort of scenario is right down here at the bottom, being able to hotfix security issues. So I assume you all remember the log4j issue not too long ago, where half the internet was exposed by this and vulnerable to this. We can actually be able to fix this with a webhook. So the way that the fix, or rather turning off the vulnerability worked, is to set this log4j format message no lookups environment variable to a specific value to then turn off the code path that was vulnerable. And we can actually do this with the webhook so that on pod creation, that just got automatically injected in all pods. So that then was no longer vulnerable. Very cool. And all these links and stuff that are highlighted here, I can share these out at a later date. If you are wanting to build webhooks, there's more than this, but that's the three most common ways, most popular at the moment is you can either build your own operator from scratch and implement everything yourself. I don't recommend it. It's a pain to deal with. Or you can use popular tooling, so Kyverno, OPA Gatekeeper, plus some other tools that are around that allow you to abstracts away some of the webhook functionality that you can then just kind of write policies, for example. So on the right here, this is a policy that we actually had to use at Giant Swarm. This is a Kyverno policy. We had an issue in our CLI tool. So the kube control plugin that I mentioned earlier, the GS plugin, there was a bug in that where it was accidentally deleting all certificate configs where it was only meant to be deleting one. So we were able to use this to then hotfix it in the cluster while we got a new CLI update pushed out. Very cool sort of stuff. There's a blog post about this if you're interested in more info. Webhooks can go wrong. So this is an area where we see most of the problems in broken clusters. So if they're not resilient enough, a webhook can take down your whole cluster. And I've got a whole other talk on this sort of thing. So if people are interested, come find me. I can talk at length about this sort of thing. If you're creating them, just be aware of things like the failure policy. So you make sure that it fails open so that it doesn't block, say, like the kube system namespace from being created. And be aware of things like the reinvocation policy, which if a mutating webhook does a mutation, whether it needs to then reinvoke another policy that it's already gone, another webhook that's already gone through. And also be aware that there's no guaranteed ordering of webhooks. It'll first do mutating webhooks, then validating webhooks. But within those two, there's no guaranteed order as to which comes before which. Cool. So Kubernetes API. I'm going to go through this one pretty quick because it's not really that interesting. But kind of everything that you use in Kubernetes, it interacts with the API in some way. In my opinion, the API in Kubernetes is the most powerful thing about it. It's fantastic. It's a very standard way of interacting with everything in Kubernetes, and you can extend it using custom resource definitions to build your own things. Very cool. You can make use of kube control to actually test out the API yourself if you're interested. So there's kube control get and then, or patch or whatever, and then pass in --raw and then the actual endpoint. You can kind of inspect it that way. And if you're interested in what APIs are available, kube control also has this API resources command that will then list them all out. Now, one thing to be aware of this, so I've got the format of the endpoint here, but be aware that if the API version is v1, so these are the core resource types from the early days of Kubernetes, these are on /API/v1/whatever. If it's something else, they've put an S in there in the path. So it's APIs/something. That's caught me out more than once, so be aware of that if you are going directly to the API endpoint. But I'm going to skip over this because there are plenty of resources where you can, there's plenty of utilities, tooling, libraries that you can actually just make use of. So if you're building your application in Go, the official client Go is fantastic. There's things like the Terraform provider, which under the hood uses it. And there's also an organization on GitHub called Kubernetes-client that has a lot of libraries in there you can use. And then you can use them to build your own automations, your own desktop applications, whatever. Cool. Final thing is custom operators. So this is where you have your own custom CRDs that we've just briefly mentioned, and then an operator running within your cluster that works on that CRD and does some sort of operation on it and leverages the reconciliation loop of Kubernetes. Now, this is a huge topic, and I'd love to go into detail, but it's a whole talk in and of itself. So if you want to learn more about how to actually build things in Kubernetes to operate these things for you so you don't have to, there are frameworks available, KubeBuilder, Operator Framework, all this kind of thing. There's some really good documentation on the Kubernetes website, and Container Solutions have also got a great explainer on the kind of intros of operators and CRDs. And I recommend these videos as well if you're interested. So we've gone through all that. Quick summary. These are the kind of things. Love your terminal. Make use of all these kind of aliases. Get into a position where you're comfortable, like at 1 a.m. having to deal with a broken cluster in a way that you're not scared of, like fat fingering a command or this kind of thing. Build things into the cluster that you can then leverage to do it for you. And that's it. All the slides and links to resource stuff is available at the link at the top or with the QR code. If you have any questions, contact me at various places or come and grab me. Thank you very much.